Hi dear students, let's see this question that came in JEE Advanced Paper-1 Physics in the year 2019. This question was from the topic of TIR, and again the question was like simple, and most of the students would have done this. This was a question based on numeric type. So let's see what's happening over here. A ray enters in this structure from air at an angle theta, and this structure is made up of two different refractive indices, n1 and n2. Value of n1 has been given 1.5 and n2 is 1.44. It is said that we want ray to come out from this end, and so that means ray must suffer TIR at every possible junction inside this. So what can be the maximum possible time taken by the ray in order that it enters from this AB and exits from CD, and speed of light in the vacuum has been given as 3 into 10 power 8. Now let's see this on the next slide. Let's call this angle, yeah, so let's say, so we want this angle to be greater than critical angle, then only TIR will happen, right? Now one thing we realize that this, if this is greater than critical angle, then TIR will happen. But we want one more thing, that time should be maximum. So if you should think carefully that we want ray to travel as much distance as possible. Ideally, we would have wanted ray to travel like this. That means it should keep on traveling. In that case, ray time will become infinite. That means if ray keeps on traveling like that. But in this case, we also want that angle should be greater than or equals to critical angle. That means if we keep on increasing the inclination of the ray, that means if we keep on increasing this angle, such that it becomes just equals to theta critical, at that instant, TIR will start happening just greater than theta critical, we can say, limiting case में theta critical. So in that case, TIR will, we can say, start happening just greater than theta critical. And we will not increase beyond that because we want ray to travel as much distance as possible. So we want ray to remain most, like inclination of the ray should be very high, but of course it should be not less than theta critical. This is what we want. And hence in the ideal case, this should be, in the limiting case, we can say this should be theta critical. Okay. So now we can see that sine theta critical is nothing but n2 was 1.44 and n1 was 1.5. So 1.44 divided by 1.5. Okay. So we can say that ray has traveled this path plus this. Now this will also be theta critical, this path, right? Plus this path. So basically ray is traveling like this. Hence we can say that, this total length is L. So if you see, let's say this is L1. So this is L1 by sine theta. Can you see that? This is L1. Let's say this is L1. So this is L1 by sine theta. Let's say this is L2 till here. This is L2. So this is L2 by sine theta c, right? Because this is theta c, this is also theta c. So this will be L2 by sine theta c, correct? So whole of this path can be written as L by sine theta c. If you think carefully, this is theta c, this is also theta c. This will also be theta c because law of reflection will be followed every time. So this is, and these will be alternate angles. So we can say that whole path traveled by ray will be L by sine theta c, right? If you can't understand this, so we can show it over here. So basically this is L1. So this is L1 by sine theta c. Let's say this is L2. So, or you can say this is L2. Even if you want, if you can say this is L2. So this is L2. So this is L2 by sine theta c. This is L3. So this is L3 by sine theta c. So you can see that whole path will become L by sine theta c, whole zigzag path. And it is also one more thing. We can say that it is independent of the fact that whether ray enters from the center or not. Like even if the ray exits like this, then also we are not bothered with that. Like we don't want this information whether ray enters from the center or not. It is irrelevant to us because as you can see, even if ray exits, let's say from here, then also this distance, let's say, is L dash. So this will be L dash by sine theta c, correct? So whatever path ray has traveled inside the this structure, that can be written as L by sine theta c. So now time can be written as total distance traveled, that is L upon sine theta c, divided by the speed of the light. Speed of the light inside this structure would have reduced by a factor of mu. So this will become c upon mu. Yeah, n1. So n1 is 1.5. Now just put the values. L was given as 9.6 divided by sine theta c is 1.44. 1.5 will go in the numerator, but n1 was already present, so it will be 1.5, and this is 3 into 10 to the power 8. When you solve this time, you're going to get this as 50 into 10 to the power minus 9 seconds. Hence, this t will be actually 50. So we can call this as t dash. So the t will be 50. I hope you would have understood. Thank you.